Hi, this is Mark Kemper with EMS. In this video we're going to demonstrate the Konica Minolta Vivid 9i 3D scanner. This is a laser-based scanner. It comes with 3 interchangeable lenses to go from a large size of about 4 foot by 3 foot to kind of a medium size of about 18 inches or 2 feet down to a small size of about 4 by 6 inches. It's a 640 by 480 resolution, so in a single scan that gives you about 335,000 points per scan. Also has the ability to scan in 3D color. And the way it works is down here is where the laser is admitted, and up here again is the lens. And it's a tripod mounted system. You can put it on a dolly to easily move it around. Weighs about 25 pounds, so it's pretty easy to travel with and set up. And it's a line of sight scanner like most of them are, so basically what it sees is what it scans. We're going to take a few scans on this engine, and you can also set it up with an automated rotary table, and we've shown that in like the Range 7 video, the Konica Minolta Range 7. For this video we're just going to use a manual rotation method just to kind of show both methods, and we'll take some scans. What's nice about the Konica Minolta Vivid 9i is it'll run direct inside the RapidForm software, so you don't necessarily have to run the standard or standalone software. You can actually scan right into RapidForm, and we're going to show that here in the demo. So what we'll do is we'll take a few scans and talk more about it. So to get started, I'm just going to go over here in the RapidForm and tell it to scan. Now I have it set up to take 3 passes. You can take anywhere from 1 to 5 passes, and each pass changes the intensity of the laser, and that's good when you're doing a part like this where we've got some dark gray, some lighter gray, and basically some different colors. So each pass of the laser is a higher intensity to pick up darker or lighter surfaces. It's a Class 1 laser, so it's eye safe. We use it to scan people for different things like medical orthotics and things like that. You can scan faces and limbs and so forth. So it took the first scan, which you see here on the screen. What I'm going to do is just manually rotate the part about 15 degrees and go ahead and tell it to scan again. And then later we'll show you in the software how you can align these data sets. But because we're not using an automated turntable, the registration will be manual. So again, the Range 7 video shows the automated process. We thought we'd show the manual process because not everybody purchases the rotary table because it is an option. But again, each scan only takes a few seconds to scan, and when it's done, the data will show up on the screen, and then we'll rotate it again and let it scan. So again, I'll manually rotate it and just tell it to scan. So pretty easy to use and set up. Doesn't take an engineer to run this with most scanners. Some basic training. Somebody can go ahead and use it. The real work is in the processing of the data, creating CAD models and stuff like that from the scan data. But other than that, it's pretty straightforward to use. And we'll do a zoom up so you can actually see it scanning the part and show you that. And then we'll go into like I said, the RapidForm software and show you how we can align and merge some of that data. Okay, so here's a zoom up of it scanning. Now the first thing it always does is a focus and sets the light exposure, and then you'll see the scan passing by. It's kind of hard to see, but if you look closely, you'll see the laser stripe go by. And I've set it this time to do 4, so you can see that 4th one was the brightest, just so it shows up well on the camera. But again, that's about it. You just really scan it, and we'll go ahead and rotate, and then tell it to scan again. And again, it'll refocus each time. Make sure it's got the correct settings for both light and distance, and then the laser stripe will pass over it. So you just continue to rotate the part and try to get a little bit of overlap in each picture. Sometimes we'll put some targets on the part, whether it be physical targets like markers, or sometimes we'll put pieces of clay or even ping pong balls, so we have some distinct stuff to line up. With a part like this, there's so much distinct geometry, we really don't need anything, and you'll see that when we get into RapidForm, it'll be very easy to line up these data sets.
Okay, so here we are inside RapidForm. There's the first scan we took. Let's turn on the second scan, and you can see they're just pretty much right on top of each other. Because we're not using the automated turntable, we've got to manually line them up. Now, something like this engine that has a lot of detail to it, it's pretty easy to do. So we do the align between scan data, and we're going to use the local based on picked point. And what I'm going to do is pick the two scans. In the window here, you see the two scans, and then over here you see one is the moving, one is the reference. Doesn't really matter which one it is. And what you do is you just try to get them in a pretty similar view, and then you need to pick at least 3 common points. So you just pick one point there in the one window, one pick there, one pick there, and you'll see as you start picking the points, it'll start to the geometry will start to line up. And you just need 3 common points, and they don't have to be perfect, just close. So you can see what it's done over in this view. It's got the data very close, and then you go ahead and execute. And what that really does is it saves the computer a ton of time in trying to line up the data with no starting point. So those look good. Let's just go ahead and display our third scan and click it, and it automatically defaults to the to be the moving. And again, we'll just pick some common points between the views, and if you don't pick the exact point you want, you can always undo it and do it again. But again, you don't have to be real critical, just generally somewhat close to the same area. And again, 3 points. You can do more if you want. And again, let's go ahead and execute it. And you can see how it's lining up those data sets. You can see that. And let's go ahead and do 1 or 2 more. So we'll just again highlight the next one and just select it. And let's rotate around. We're coming around, looks like this way on the engine a little bit. So typically when we're scanning, we try to rotate about 15 degrees or so, depending on the object, just so we get some good overlap between the scan data. The more overlap you have, the better when you go to line up the data later. If you don't have enough, you theoretically could have problems when trying to align it. So again, get it close, and we'll go ahead and hit the button to go ahead and execute the command. And again, you can see what we've done here. So we've aligned 4 data sets, and we would continue to do this until we have them all lined up. Okay, for time purposes, I went ahead and lined up about 6 or 7 more scans, and you can see they all kind of bleed through each other, and that's again what you want when you line up scan data. So you can see we've got most of the top of the engine here. We would actually set up adjust the scanner angle to get the bottom of the engine. We were using the medium lens, so you get an idea of how much data you can capture at one time. So you would go around, rescan the bottom area and bring that in and line it up, and really just complete that process. And then the next step would be to merge all the data. Now I'll go ahead and just merge what we have on the screen so you can see what that looks like. So to merge, what we do is we just go under our scan tools. We tell it to merge. I'm going to select all the data, and I'll go ahead and execute the command. And this will take a few minutes to process because you're dealing with about 10 different scan files here. So it takes a few minutes when you're doing some of these larger calculations. Okay, for time purposes we paused the video, but again you can see here this is the merged data, so you can see what the data looks like. Data is pretty good quality, and you'll see some holes in the data, but that's okay. We're going to be doing a feature-based solid model from this scan data, so this will be more than enough data because it doesn't have to be perfect. Not every hole has to be filled in, because we're really going to use this data as reference to build solid body geometry and create a feature-based solid model. So what I'll do next is I'll actually load up the final model and show you what that looks like. Okay, so what you see here is the actual finished feature-based solid model with the scan data overlaid it. So let's go ahead and shut the scan data off for a minute, and you can take a look at the actual completed model. So it took us about a couple hours to scan it and then align and merge all the data, and then took a day or so to create this actual feature-based solid model. But that's one of the real advantages in rapid form, is we can take that raw scan data and create a very high quality feature-based or surface model. In this case it makes total sense to do a feature-based solid model, and you can see the results from there.
Okay, so that wraps up this video on the Konica Minolta Vivid 9i system. Overall, it has good resolution, good accuracy, has the ability to use 3 different lenses to go from, again, pretty good size of about 4 foot by 3 foot down to about 4 by 6 inches. We'll scan in color as well. We'll work with the turntable, or you can just manually rotate the parts. Pretty portable system, and really just works good with a whole different variety of applications. So if you need to do kind of small to large parts, it's a good fit. Also works with photogrammetry systems, so if you are doing something large and you do need some high accuracy, works well with that. So overall, it's a good system when you have when you need a lot of versatility.